Okay, so today, guys, I'm recording. You're live. So 12, 11, 9, 18. So similar figures. Let's just put down same shape, different size. Okay? Same shape, different size. So if they have the same shape, then what we're going to know is this. We know that their angles, their corresponding angles will be congruent. Okay? So if I take a look at these two figures here, I know that angle C would go to angle F. They have to be the same size, to be the same shape, but I know that angle A would go to angle D. It has to be. If they're going to be the exact same shape, then the angles have to be the same. Okay? B and E have to be equal, right? Same shape, they've got to have the same size angles, right? So they show us A is equal to D. It has to be. If they're similar, and this is the symbol we use for similar. It's not equal. You can see it right up here. It doesn't mean equal because they're not equal. It doesn't mean congruent. This little symbol means similar. They're not equal. This is the symbol saying they're similar. Same shape, but different size, okay? So if that's the case, A is definitely equal to D, or congruent. Same angle. B would correspond to angle E. They're equal. And angle C would be congruent to angle F. They're corresponding angles. So these are called corresponding angles, or corresponding parts, because they match up. So these are corresponding, okay, corresponding angles. All right, that's pretty easy. You know, if they go together, they're corresponding, right? Now, turns out that if this was twice as big, then they'd have a scale factor of 2, right? So they have a ratio. We could say this side, this is really important, this side over this side would equal this side over this side, would equal this side over this side. Okay, let me say it this way. Let's say it's twice as big. So then this side's twice as big as this side. This side's twice as big as this side. This side's twice as big as this one, okay? So we'd say that the corresponding parts are proportional, okay? So we're going to write angles are congruent. Okay, corresponding angles. But our sides are not congruent. No way. Because you got a big one and a little one, right? Sides are not congruent, but they are proportional. And the word proportional means fractions that equal each other, okay? So we can say the sides are proportional. And proportional simply means fractions that are equal. Simply means fractions that are equal. Okay, how am I doing? So far, so good? Yeah. How am I doing? Okay. Now turn the page. Okay. And now it briefly talks about what we just said. We talked about the perimeter, okay? The perimeters are proportional. So this is a whole lot of math, but it's saying this don't let this confuse you, but to do perimeter, you just add side plus side, just adding the sides all around. This side plus this side plus this side plus this side. That's all it says. We're adding the sides for perimeter, right? And we're saying that the perimeter has the same ratio as the sides. So the perimeter has the same scale as the sides. Example, if this figure is twice as big as this one, if this one's twice as big as this one, then each side would be twice as big, and the perimeter of this one would be twice as big as this one. It's that easy. But the area is different. You see this little square here? It's different. So if you had a scale factor, I'm going to put down some examples. Let's look at the two figures. If you had a scale factor, let's just say, let's make up two little examples. Let's do a scale factor. Okay, I have two examples, scale factor. Well, and now it doesn't look right, but let's just say, hypothetically, that this one's 3 times as big as this one. This one's 3 times as big as this one, okay? Okay? that means the area 3 times as big, right? 3 times as big. That means the area would be 3 squared times as big, or 9 times as big, because you increase the base and the height, changes it from 1 dimension to 2 dimensions, so it's going to be 9 times as big. Okay? Let's just say hypothetically, I'll let you catch up. Let's say hypothetically this one is 3/2 as big. Okay? Let's say this one's just hypothetically 3/2 as big. Okay? Or the scale factor is 3/2. Okay? It's like 1.5 times bigger. Okay? So then the perimeter will be 3/2 as bigger, but the area would be 9/4 as big, because I took my 3/2 and I squared it. Because when you go from area, you're going to increase the base and the height, so both increase by a factor, right? Okay. Now you still have your sheet. Okay. You still have your sheet. Okay. All right. Take your sheet and let's look at the back. Okay. So, you still have your sheet. Let's take a look at the back. Okay. So one of the things we're going to learn in here is that similar figures are proportional. Okay. So proportions. Okay. Proportional. Okay. The word proportional simply means a fraction that's equal to a fraction. It's a fancy word. It just means, Hannah, are you taking notes? Of course you are. It just means a fraction equal to a fraction, okay? So, how would we solve for x? We're going to cross multiply, right? Cross multiply. So, we're just simply going to go 5 times 8 and 8 times x. Cross multiply. We're going to multiply this across. 8 times x is 8x. 5 times 3 is 15. We cross multiply. A fraction equal to fraction. The easiest way to solve it is by cross multiplying. Jay, you watching? Okay. Divide by 8. Divide by 8. X is equal to 8/15, which is really 1 7/8. Okay, that's easy, right? We've done that before. Okay. Number 2. Same kind of problem except for x is on the bottom, but still fraction equal to fraction. Cross multiply, okay? So I'm going to take this times this times this. So we get 5 times 7 is 35. X times 6 is 6x, right? Divide by 6. Divide by 6. Let's see, what is that? 5 and 5, 6. 5 and 5, 6 is x, okay? Easy, right? Pretty easy?
Yes.
Number 3, a little bit more complicated, but then it's the same process. You've got a proportion, you've got a fraction equal to a fraction, right? So we cross multiply, okay? So we're going to go this times this, or 6 times x plus 5, equals this times this, or 3 times x minus 3. Okay? We just cross multiply. I'm going to take the 3 times the x minus 3 and the 6 times the x plus 5. Okay? And then multiply. Okay? Distribute. I get a 6x plus 30 equals a 3x minus 9, right? Minus 3x, minus 3x. 3x plus 30 equals negative 9, right? Minus 30. Am I going too fast? Minus 30. 3x equals a negative 39. Divide, and x is equal to negative 13. Okay, thumbs up so far? Okay, this is going to come up in our homework, but we're going to have figures that we have to set fractions. That's why you got to practice this. How about number 4? I'm going too fast? Okay, cross multiply, right? Fraction equal fraction. This times this equals this times this, right? And I'm going to get an x times an x plus 2 equals 2 times 4, which is 8. Okay. Sierra. Okay. Sarah, you haven't written anything down.
I just got it.
Okay. Hannah, you have nothing. Okay. This times this times this. Okay. X squared plus 2x equals 8. Uh-oh. Uh-oh. It's the F word. It's the F word. We're going to have to factor. It's the F word, right? We're going to have to factor, right?
Yeah. I thought it was something else.
No, just almost as bad, huh? So bring over the 8. So if I bring over the 8, right? X squared plus 2x minus 8 equals 0, right? Factor, factor, right? Remember how to factor? X, positive 4, negative 2, right? We got our little mini equations. One answer is x equals negative 4 and x equals 2, okay? So we're going to need to know how to do that because what I want you to do now is pick up your journals one more time, okay?
No way.
Yeah. So let's check out problem number 1 on page 263. Page 263. Okay, here we go. Now, these two rectangles are obviously similar, but the problem is that they're not written correctly. But I think the x goes to the 7. You guys agree? So the x goes to the 7. See, I wrote that out. X goes to 7. See, I'm setting up my proportion. X goes to 7 as 2 goes to 3. So I went small to big, small to big. Don't mess it up. I went small figure to big figure, small figure to big figure. I went long side to long side, so my proportion I set up correctly. And now we're just going to cross multiply, right? Cross multiply, that's easy. That times that times that. I'm going to get a 3x equals 14, right? Divide by 3. X, let's see, divide by 3, divide by 3. Let's see, what is that? That's going to be 4 2/3, right? Thumbs up? So the trick is to just set it up correctly. Now, you could have done this one differently. Could have gone 7 goes to x as 3 goes to 2. That would have worked. You watching? You could have also gone 2 goes to x as 3 goes to 7. You just have to be consistent, okay? Number 2. All right, the x. I think the x goes to 25. You guys agree? Doesn't the x go to the 25? I think the x goes to 25. You guys agree?
Yes.
And I think then it doesn't really matter. You want to go 30 to 12? How's that? Great question. Yes, we should. If they are similar, we should get the exact same answer. Thank you, Ellie, for asking that question. I was hoping somebody would. So, we're going to set it up. Now, watch carefully. Are you watching? You can set this up totally in many, many ways. So, for instance, I could go x goes to 25 as 12 goes to 8. Watch. I could go 25 goes to 30 as x goes to 12. I could go, let's see, I could go 30 goes to 12 as 25 goes to x, right? I cannot do this. Watch me do it wrong. I cannot go 25 goes to 12 because they don't go together, do they?
No. Wait, what?
So there's like about 6 correct ways to do this. Let's just pick the easiest, okay? Pick x first. X goes to what? Everybody agree with that? And if that's the case, we're going small to big, right?
Yeah.
So we've got to go then the 12 goes to 30. Does that make sense? As 12 goes to 30. Yeah, Ellie, question.
Can't you just look at it and say that it's a 4, 5, 6 triangle and find out the scales?
Yeah, and that's what we're doing. In fact, the scale's right here, isn't it? The scale is right there.
Yeah, no, I know.
Yeah. Okay, cross multiply. So Ellie, yes. Okay, cross multiply. I'm going to get 30x equals, 25 times 12. Let's see, 12 quarters, isn't that $3? 12 quarters. Isn't that $3? 300? I could use my calculator. What's 25? 25 times 12, 300. Divide by 30, x is 10, okay? Got it? Okay, we're going to do this last one and we're going to be done, okay? Okay, scale factor. Scale factor. It's right here. Here's our scale factor. Do you see our scale factor? It's right there. It's 2 to 3 or it's 3 to 2. I'm going to go 3 to 2 because then I can deal with an easier fraction. So my scale factor is 3 to 2 or 2 to 3. Either, now it makes sense. Either this one's 3/2 bigger or this one's 2/3 smaller. I'm saying the same thing. I'll say it again. This one's 3/2 bigger, or this one's 2/3 smaller. Really saying the same thing. I'll say it a better way. A figure could be twice as big, or the other one could be half as small. I said the same thing, didn't I? Yeah.
Look at number 4.
Find the scale factor. I just did it. Okay. Oh, it's going backwards. Oh, you're right. So this one's going to be from here to here. It's going to be 2 to 3. Thank you very much, Caleb. Same thing, right? Okay. Now find the values x, y, and z. Okay. So first of all, x. Let's get z first. You guys okay with z? What do you think z should be?
45.
45. Agree? 45. Because the angles have to be equal, right? So z's got to be 45 degrees. So I got z equals 45 degrees. Where's x? Oh, here it is. Okay.
90.
Now, if you're not sure, x is a side. So we have to set up our scale. So I'm going to go, you ready? I'm going to go x goes to 1. X goes to 1 as 3 goes to 2. X goes to 1 as 3 goes to 2. See how I set it up? This side goes to this side as this side goes to this side. Cross multiply, and I've got a 2x equals 3. Divide by 2, divide by 2, x is 1.5, okay?
Wait. I'm going to find the angles.
They wanted the angle for c, but now they want the sides. X is a side, right? So x is 1.5. That means this is 1.5 also, right? Now y, right? Okay. Okay, these two go together, right? It's a side. So I'm going to say, okay, well, I'm going to say y goes to 3 square root of 2, right? As 3 goes to 2. Y goes to 3 square root of 2 as 3 goes to 2. Okay, I'll set it up again. Y goes to 3 square root of 2 as 3 goes to 2. See it? Okay, now cross multiply. Cross multiply. Bring this up here. I get y equals 9 square root of 2 divide 9 square root of 2 divided by 2. Okay. Yeah, but then I'd have to divide by 2. I skipped a step, didn't I? See why I skipped a step? Because I'd have to divide by 2 anyway, right, Quinn? Yeah. Okay, so now, what's the perimeter? Oh, man, the perimeter's going to be a pain, but I could add them all up, right? 2, 3, 4, 5, 2, 3, 4, 5, 6, right? 6 plus 3 square root of 2, right? This one's got to be twice as big. Don't even bother counting. This one's twice as big, right? Don't even bother counting. Isn't it twice as big? So this one would have to be 12 plus 6 square root of 2. Twice as big. Okay? So the ratio is 3 to 2. That is my ratio. Or 2 to 3, right? Now what about the area? Okay? What's the area of these darn things? Well, I'm going to skip the area because I'm going to run out of time.
Is it just 2 divided by...
Well, what I would do is find the area of the triangle and then subtract out the whole. I'll do it. Let's find the area. So this is 3 by 3. So the area is 3 times 3 divided by this whole. This whole is size of 1. So 3 by 3 divided by 2, and I'll subtract out the whole. So it's 4.5 minus 1, which is 3.5. Okay, here's the easiest way to find this. Okay, if I lost you, forgive me, okay? Triangle, base times height, okay? And then let's subtract out that square. Okay? The area of the other one?
Can you scoop it up a little?
Yeah. So that's the area of the small one. The area of the big is going to be this. You ready? 3.5 times 3/2 squared. Okay, this is where it gets hard. Okay, so the scale factor is 3/2, right? But we're going to a second dimension, so in our notes it said square the scale factor, right? So I squared the scale factor. So I'm going to go 3.5 times 9 fourths, and I'll just use my calculator. I'll go 3.5 times 9 fourths, and I get an answer of 7.875. All right, that's a little bit harder, but that's okay to have some hard stuff, right? Okay, I do have homework for you.